In this problem, we are given the population model of a city P of t, and this equals P of t equals 234, 252 e raised to the power of 0.15 t, where t is the number of years. And we have to determine the number of years so that the population reaches 1 million. So basically, we have to determine t when P of t equals 1 million. So I'm going to substitute P of t equals 1 million into this population model and determine the t. So let's do that. Replace P of t by 1 million. 1 million equals 1 followed by 6 zeros. This is 1 million. And this equals 234, 252 e raised to the power of 0.15 t. Now to solve this equation for t, we can apply natural logarithm to both sides. But before that, I'm going to divide this both sides by this quantity. So let me do that. So when I do that, I get 1 million divided by 234,252. So this equals e raised to the power of 0.15 t. Now we can apply the natural logarithm to both sides. So I'm going to apply natural logarithm. So write down this as natural logarithm. In fact, I can also apply the natural logarithm to this side. So therefore, this becomes a natural logarithm of e raised to the power of 0.15 t. Now we apply the power rule of natural logarithm. So which means this power will come in front. So in the next step, I can rewrite this as this quantity remains as it is. So I just write down this quantity as it is. That is natural logarithm of 1 million divided by 234,252, and this equals 0.15 t times of natural logarithm of e. We must be knowing that natural logarithm of e equals 1. So this is a standard value which we can replace it over here. So when this is replaced as 1, we will have only 0.15 t on the right side. So I'm just going to remove this from the right side. So on the right side, we have only 0.15 t. So if I remove these brackets, it looks like 0.15 t. So we can easily solve for t by dividing both sides by this quantity 0.15. So I'm going to write down this expression for t. This equals, this is we have on the left side. I transpose it to the right side. This is natural logarithm of 1 million over 234,252 all over 0.15. So we can plug this value into the calculator, and when we do that, we approximately get the t as 9.68, and this is in years. And we round this to closest year or to the nearest year, we get t approximately 10 years. So it takes 10 years for the population to reach 1 million.